Buena, buena, buena. Em, bueno, lo voy a hacer en inglés. Okay, so today we're going to solve the first few problems from this year's Advent of Code. Um, and we'll just jump right to the exercises. Um, so it starts. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the slide keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights, because of course it is. And it even has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So basically, the Advent of Code is a yearly event where there are usually 50 puzzles, programming exercises to solve. So yeah, let's just jump right into it. I'll open a console, an interpreter. I'm using Ruby to solve the problems. So yeah, we'll play around to see what happens here, and when we have a solution, we'll just write it in the proper way. So the first puzzle says, as a submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep look further and further away from the submarine. For examples, suppose you have the following report, and we have a bunch of numbers. This report indicates that scanning outward from the submarine, the sonar sweeps found depths of 199, 200, 208, 210, and so on. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. So we have 2 measurements, and we have to know if the next one increased from the prior one or not. There is no measurement before the first measurement. In the example above, the changes are as follows. So please note that I already solved the first 2 exercises, but I'm going to solve them again because I don't really remember them, and I didn't take any notes. So yeah, we'll start by playing with the actual example here. We'll try to make it right, and then we'll see if it works for our input. That I guess I should be. Oh fuck! I'm not sure if I can get my original inputs. Oh yeah, I can. There they are. Oh, so it's the same input for the first two exercises. Okay. Um, so we'll start by creating an array with all the numbers we have here. We'll type them by hand because there are just a few of them. Okay, so since we have to always compare two numbers, we have to compare the 2 consecutive numbers. There's a really nice function in Ruby that lets you have an array or any kind of an enumerator and make a new one that has groups of any quantity of consecutive elements. So we'll rename this to depths. So it's clearer what we're dealing with. And we'll call each cons with the argument of 2 that will make a new array with the all of the pairs. So now that we have the pairs, we just have to count. So we'll use the count method. Um, um, and we'll just count the ones that meet the condition, where the second number is bigger than the first one. So in that case, the subtraction should be positive. I think we can do something like this. Yeah, so it's 7. This is precisely the answer for the example. So we'll go grab this input. And we'll make a file. We'll try to read from here. Yeah, so we can get it. If we split that in lines, we have the array. We will convert all of these strings to numbers. And then we have another depth array. So we can replace the original depths array we have with with this new one and just call the method we have called before. So in any case, if you want to see what is happening here again, we're calling each cons to make consecutive pairs of numbers for all of these input of depths. And then we are counting all of them that meet the condition where the second one minus the first one um, just a sec. Oh no. Okay, so all of the pairs that meet the condition where the second one is bigger than the first one. So we got 1393. I guess that was the original answer. Okay, yes. And then we head to the second part. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. Instead, consider sums of 3 measurements sliding window. So we'll have 3 consecutive numbers. We'll sum them, and that will be one of the inputs. So considering the above example, here we have the three items windows. So we'll start by comparing the first and second 3 measurement windows. The measurement in the first window are marked 199, 200, and 208. Their sum is 607, and the second window is marked P, 200, 208, 210. So these 3 numbers, and then these 3 numbers. Its sum is 618. So the sum of measurements in the second window is larger than the sum of the first. So the first comparison increased. So it's essentially the same thing as the first exercise, but instead of grabbing pairs, we'll sum each 3 consecutive numbers, and then we'll grab pairs of those numbers. Your goal now is to count the number of times the sum of measurement in this sliding window increases from the previous sum. So compare A with B, then compare B with C, then C with D, and so on. Stop when there aren't enough measurements left to create a new 3 measurement sum. In the above example, the sum of each 3 measurement window is as follows. So we have here we have the result of the 3 sliding windows. So we'll start by constructing those 3 items windows, whatever it is, and then repeat the exercise as we did before. Once we have done that, I'll write the code a little bit more cleanly so you can see, and then I'll share it on a repository. Okay, so the first thing we want is to get our original input um, back so we can work with it. And we'll try to construct the three item windows. So we'll use the same method we used before, that it is each cons 3. So that will get us an array of three items, an array of 3 continuous items, and we'll do a map on them, and we'll make sum. So each of the arrays is going to be summed into a single item. So here we have the same windows that we're shown on the exercise. So if we use this as the depth for what we originally did to count the pairs where the second item is bigger than the first one, we could do just that. So why am I doing this? Why am I doing this on just a single chain? Because since we have just a single input and we have just a single output, we are talking about a single query. If we don't care about the intermediate steps, there's no need to separate them. But when we write the method a little bit more clearly, we can see how we can make this make a little bit more sense and maybe refactor it into more methods. But it is essentially something like this. So okay. So we will get our input back from the file. Now we have all of the numbers from the file, and we'll call the method we just made. So the answer it is 1359, and this is the answer I already submitted. Yes. So we'll write this in a file and maybe make it a little bit more clean. So we'll give it a mouthful of a name just so we know what this is doing, because we're writing all of the code inside. So the input for this is going to be an array of numbers. So we'll call this depths, and we'll just copy the code we just wrote. So it is for the first exercise, it is we first make the pairs of items, then we count the items that meet the conditions. So there. So it should look something like this. I think we could deconstruct the array just on the block, but we'll see. So to call the method, we'll read the file. And we had to split this, and then make them into an integer, right? So we'll put the result. And if we were to run this, let's see what happens. Yeah, it outputs the correct number. So this would be the first exercise, and the second exercise. times math window. So this is essentially very similar. We have our depths. We group them on groups of three. Then each of those groups, we sum them. So that is using map. And then we have to treat this just as a regular array of depths. So we could even call the upper method, you know? So we'll assign this to a variable. Maybe we can do this on one line. And then we would call number of times depth increased with the depth windows. And we'll also have a puts with that. Uh, depth window. Oh, window increased. Yes. Yeah, okay. So we got the correct answers. So um those are the first two exercises. We're going to proceed with the second pair of exercises. And in a next time, we'll grab the ones we just wrote, and maybe refactor them in something that makes a little bit more sense. I'm with a friend here, and he says he has a question, so I'll hear his question and maybe try to answer it. Go on. Um, oh yeah, yeah. That's a pretty newbie error. I think a mistake. Yeah, he says if I can change the subtraction and positive method for just a comparison, and that's totally right. So we could do something like if the last one is bigger than the first one, it should be something like that. And I also said maybe we could deconstruct this. So where's the chat here? Ah, yeah. So there are a lot of ways we could organize this. So he says we could either maybe grab this line of code here and turn that into a method, and then call the original one from upside with that. So we could make something like this. Um, depth window, and we could even make depth and size, let's say, and we could grab this and throw here this in here. And then do something like this. Something like this. So yeah, that's totally another way to make that. And maybe we could keep making changes. For instance, we have some magical numbers, that two there and that three there. Maybe we could put some more significant names here and there. So yeah, it's always something that can constantly be improved. But yeah, I fucked up something. Uh, oh yeah, I inverted these two. Yeah, that's totally right. So that would be the first exercise. Let's move on to the second one. I haven't done any more than this, so all of the next ones are new for me. Um, but yeah, I think we can do a little bit more. Maybe this pair of exercises, and that would be it. So day two, dive. Now you need to figure out how to pilot this thing. Remember we're on this submarine, and we have just calculated how the depth of the ocean progressing forward goes. It seems like the submarine can take a series of commands like forward one, down two, or up three, where forward X increases the horizontal position by X units, down X increases the depth by X units, and up X decreases the depth by X units. Note that since you're on a submarine, down and up affect your depth, and so they have the opposite result of what you might expect. So yeah, going down increases our depth because we're going farther down the ocean. We're going deep into the ocean. So down increases and up decreases. The submarine seems to already have a planned course, your puzzle input, and you should probably figure out where it's going. For example, if we had forward 5, down 5, and such, your horizontal position and depth both start at 0, and the steps above would then modify them as follow. So we have the total values for our horizontal position and our depth, increasing or decreasing with each instruction. You know, so after following these instructions, you would have a horizontal position of 15 and a depth of 10. And multiplying these two numbers together would give 150. Calculate the horizontal position and depth you would have after following the planned course. And what would you get if you multiply your final horizontal position with your depth? You have your depth and your final position, and you have to multiply them together. So we'll start by yeah. So we'll try with the sample first, and then we'll grab our input and maybe see what happens. We'll start a console just like last time. We'll take the input directly here, so we can just copy it. I think that's okay. So yeah, we have our input. Mm, so what do we want to do with this input? This input is a whole of lines, a bunch of lines, where each line is an instruction. So first thing we'll do is split it on lines. We'll first split them on lines. So we can have each instruction on each line. Then we will each instruction we will split it down on. Oh, maybe not. Maybe we can do this. If we split it all down, we will have word number, word number, word number, word number, right? Then we can call each cons, the method we used before. So we can have each instruction on an array of two elements, the instruction and then the oh no, this won't work. There's another method for this, I think, that would be maybe group or something like that. I don't know. Let's look. Yeah, yeah. What I was thinking was making a split for each line and then grabbing each line and have it split, you know. But that would be two methods because I would have to take um I would have to take first split all lines and then each line split it into two elements. And I think if I do one split, I will have oh well, it's still two calls, you know, because yeah, there's no way to make it on one call, I think. But it's a good time to check if there's another method. What? I'm sorry. Yeah. Well, in one statement, yeah. So I think it maybe is cycle. No, it's not cycle. I think there is a method, append a sock, search, clear, collect, deconstruct, difference, drop, each empty, equal, fetch, fill, filter, find, first, flatten, hash, include, index. I know, I think there is a min max, all to S1, pack maybe it is? No, I don't think it's pack. Each slice, I think maybe it's something like each slice. Oh, but those are enumerable methods. Yeah. So here, yeah, so here in Ruby, it's called each slice, I think, and yeah, it's called each slice. So that will give you no, well, I think if we do just a slice, that would give us an array right away. No, no, it doesn't. No, that it slices the array. No, yeah. So it's each slice. No, here what we'll do, I think it's using group by. So group by usually takes a block where you can for each element you can map it to a certain value, and then you'll get a hash with all of those grouped with that value as a key. Um, so I would usually do something like this: instruction, instruction, and value, and we could group uh, by instruction. You know, so we'll get a hash where we have the forward key, we have all of the three forward instructions, and then the down, and then the up. You know, so but we can do this in a little more concise way if we do first just a call to first. um yeah, but I'm not yeah, I'm not sure about it, so I'll just go with this. And maybe I can look that up later. But yeah, there might be some way to do this even in a more concise way. So here we have a hash, and we have so for each instruction we have one key, and then the other ones. So then we are going to transform the values because we only care about the number, right? So each value is an array of instructions. So for each array of instructions, we're going to go through each instruction and we're going to only get the number. Um, so that is instructions, map, and the second one, right? the last in this case, right? And then we'll map them again. Then we'll map them. No, in the inside this map, what we're going to do is we're going to do here is oh yeah, instruction last to it, right? Yeah, and then we can just call some um no sum here. You know, after we map them, we can call sum. So we have all of these forward sum, all of the down sum, and all of the up sum. One one thing about this that we're not considering, but is also not a state on the problem, is the corner case in which you can go down and then you can go up. And if you had, for example, down 6 and then up 7, you would supposedly be like on a negative depth. But yeah, the I think the input won't have that corner case either. So but yeah, that's something you would consider. For example, if this was a real if this was a real problem you were facing on real life, you would ideally want to think about all of the corner cases. So here I am assuming that you're never going up from, you know, like up from the the ocean limit. You know, you're not flying on the submarine. So yeah, if we were going to, yeah, we have the hash now. And since what we want to do is multiply the final depth, which is constructed from the down sum and the up sum, and then multiply that with the forward. So what we're going to do is tap. No, it's going to use then. So this is some really nice method, and we'll see when we write this clearer how this make code looks really nice. Because yeah, in one line everything looks like shit, but then when we tidy it up a little bit, it will look nicer. What then does is grab the thing we have, in this case the hash, and throw it inside a block, and let us give it a name inside that block and use it, and then return the result of the block. So here we have the sums of instructions. Let's call it that. And we want to have the forward, the forward. That's everything we went forward, what we advance, multiplied with the subtraction of both of the other ones. So we will have multiplication here. I know this doesn't look really nice. Maybe let's sum into this. I'm sorry. Just give me a second. Yeah. I wish I could write this on. I guess I can. Oh well, fuck it. Yeah, we'll just call it sums. It's easier, or maybe even yeah. Uh, what? Yeah, since we're at that, so we have the forward. That's pretty straightforward. No pun intended. So so yeah, this is a string key. And then we'll have the sum of, no, the subtraction of the other of the other two ones. So we have to subtract down minus up, because we're going down and then minus up. That would give us our total depth. Remember, we're talking about depth. So this would be down minus up. Yeah, and if we multiply, we have 150. That's what we had here. So let's get our input. I'm going to copy it all. I'm going to throw it out onto a text file. We'll save the text file. So yeah, we'll throw this. So for example, no, yeah, we'll make this into the input. I was thinking about using then, but yeah, not on the terminal again. So does this make any sense? I don't know. I don't have a clue. Um, maybe let's do if each let's see if each step is making sense. So then we call each slice. Yeah, I think it will make sense. I think the input is well formed. So this says it is uh, this biggest number. Yeah, so that's the right answer. I get a 1 gold star. I have 3 gold stars now. I'm closer to finding the slide keys. Let's continue to part two, and then we'll end this video for now. So the part two says, yeah. Oh yeah, yeah. I'm definitely going to save all of this on files, and I pretend that we can later revisit them and refactor them as if that code were part, of something bigger, like if you were working, let's say, in your job or in your company. Of course, you would never maybe have to face a challenge precisely like this, but it could be a part of a bigger problem, and you would want to write the code as tidy as you can. So if you had to expand the code, or maybe make some modification or some change, it would be easy. So maybe we can make a different stream to have these solutions, and write them in a style that would look a little bit more like what you would write on a bigger project. Because of course, if we just want to solve a little puzzle, we will not probably create a lot of classes and a lot of shit. But if we were talking about a real job, or what we are really talking about a real project, we would like to write it better. So, okay, the part two says, based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you will also need to track a third value called aim, which also starts at 0. The commands also mean something entirely different than you first thought. Down increases your aim by X units. Up decreases your aim by X units. So essentially, what we thought would be for depth, it's called aim. And forward does two things. It increases your horizontal position by X unit, just like before. And it also increases your depth by your aim multiplied by X. So essentially, our aim is like a kind of angle, like is that right? Angle? Is that a word? Um, so it's kind of an angle, and when we go forward, we're going like, instead of just this, we're going like down. So yeah, it's a little bit different, and maybe for this we would want to write better, you know. So we're going to quickly write the code we just did. So yeah, yeah, solving this in the console, I think it's going to on the interpreter, I think it's going to be a little bit harder, but yeah, let's do a file. So, but first I'm going to write the one I just solved, so we can have the solution there to see, because it's probably going to look a lot similar. Oh yeah, I really suck at copy pasting. I usually retype the things, but just because I really like typing, so. But yeah, people always ask me like, why don't you just copy paste it? And I'm like, oh yeah, I should do that to save some time. So yeah, we have here in a vlog inside a vlog. That's something we would probably probably wouldn't want usually, but we can make some concessions here because as I said earlier, we are just we didn't care about intermediate results. So there's no need to extract them just now, you know. Yeah, I think I have one. Where? Oh yeah. So yeah, it would look like something like this. Yeah, we will call this solve. Yeah, sure, sure. So I know you don't hear my friend, but he's talking to me and he's giving me some advice and maybe asking me some questions. Sadly, OBS on Mac doesn't let you um, share the audio you're hearing. Um, or not just right away. I think you have to set some things up. But so I'm talking to him. Um, he asked me to run this to see if I copied it right. Yeah, yeah. Yeah, and I can actually do something here that I really like to do. I'm really a fan of while loops on the shell, you know. So we'll do something like something like this. Yeah, but 5 seconds are I think way too much. So I like doing this when I develop, so I can get constant feedback of what I'm doing, especially if I'm not doing test. But usually I would run my test on this loop. But if you don't have test, if you're programming in a light way, you know, like maybe just solving some puzzles, it maybe doesn't matter. But I'm going to delete these puts for now, and I'm going to put um, the other one that's not going to output anything for now. Yeah. So again, note that since you're in a submarine, down and up do the opposite of what you might expect. Down means aiming in the positive direction. Now the above example does something different. Forward with will add 5 to your horizontal position, a total of 5. Because your aim is 0, your depth does not change. Okay, so thing is, every time we read a forward, we're going to change both our horizontal position and our depth. So I think there's a fundamental difference in this case with the one we did before, because here the order does matter, because the aim changes the way the forward instruction works. So we have to do it step by step, essentially, you know. So there's a bunch of ways we could do this. I'm going to start, I think, because yeah, yeah. So yeah, so what we would preferably like to do in this case, we're still talking about queries, you know, we are still talking about some input and some output. So there's one thing, people who do object-oriented programming, that's what we're doing using Ruby, can learn from functional programming. Or well, we can learn it elsewise, but functional programming is it's really aims at this. The difference between what a query is and what a command is, or what kind of methods have side effects and which don't. You know, in a purely functional programming language, you would just have queries. You know, you would just have methods that make calculations. So if you don't know what a query and a command is, essentially a query is a method that takes input and makes output, but doesn't have any side effects, doesn't change none of the things you gave it. They are not changed, they are not permanently changed. For example, if you have an array, it doesn't change the array. And a command is the opposite. It's a method that doesn't have a result. It doesn't return a value, but changes the state of something. And in Ruby or on object-oriented programming, we tend to sometimes have a bunch of queries and a bunch of commands all tossed in together. So um, arguably, a better way of programming is separating queries and commands and having them live, you know, like each one of them living separately, you know, being usually the commands your like doors to the application. I don't know, I don't have the word right now, like your gateways to the application, you know, the places where you ask the application to do something. Those are the commands, and the queries is everything that's happening internally to calculate the right values for things, or to make whatever your app does, you know. So for example, in a Rails application, the commands would be related to saving to the database and stuff like that, and all of the other stuff could be done purely with commands. So yeah, thing is, when we do object-oriented programming, we are probably more accustomed to having internal state and dealing with that internal state by modifying it and such. So since we have to do this step by step, yeah, let's hear how this all of this goes. Yeah, you know, but we'll try to do this in a more functional way. So we have our input, and we're going to split it and then do the each slice, and that would be an instruction. So we're going to make a method that creates all of the instructions for the input. So it takes an input and returns all of the instructions, uh, all of the instructions. You know, so this we could even um, maybe refactor this a little bit. But yeah, essentially all of this is part of having the instructions. So the group by makes the hash. Oh yeah, we'll have just the array of we'll stop at the array of instructions. So we have our instructions. What we want to do is each time we read an instruction, we want to create um, a result. Um, if we were dealing with internal state, what we would do probably is something like this. We would initialize our result in zero. We would initialize our depth in zero. So we're going to start doing this, and we'll then going to change it to something more functional. Um, we have our horizontal, like our horizontal position. I don't know how they horizontal. Yeah, the depth is right there. Uh, horizontal, yeah, and the aim is zero. We have the aim. So we would do instructions. Each do instruction. Yeah, yeah, and then we would say case instruction first. That remember that the instruction here is something like, oh yeah, something like this. Yeah, so okay. Um, I'm going to fill this up. So I'm a real fan of statements more than if else statements, because the if else statements and even more if you add else ifs statements kind of have an innate hierarchy, like the if part is more important than the else part usually. So when that's not the case, I would usually use uh, a case statement, because all of the branches are kind of the same. In fact, we could use a hash here, and that's what we're going to do later. But for now, let's go with the case. So if the forward one is the harder one. So we'll deal with the later. When we read up, the aim decreases. So aim should be minus equal to the value. Then when we read down, it's the opposite. Mm, we add we increase the value of the aim. And on the forward case, it's a little bit different because it does two things. The first thing it does is increase your horizontal position, horizontal by the value, and then it increases your depth by your aim multiplied by the value. You know. So yeah. Um, I think. Oh yeah. I think. So let's see, we have to return the multiplication of the horizontal position and the depth. The same thing. We would do depth times horizontal. So all of this time, this loop has done nothing because I haven't printed anything. it would have been maybe useful to print something, but yeah, it doesn't really matter that much. So here our value is a string, so that's something we're going to change here. Yeah, that's a huge value. I think that may make some sense. Uh, oh yeah, yeah. Let's check with the example input. Um, so yeah, the example input says 900, and that is the correct answer. I think it says, yeah, here 900. So yeah, it's fine. Mm, we're going to submit the answer. And yeah, that's the right answer. I got another gold star. I'm closer to finding the slide keys, and I have completed day two. So if I return to the advent calendar, yeah, there's not pretty much to see yet. This should supposedly form an image, I think. So that's it. That's it for today, I think. Yeah, that's been like anyway for now. I'll keep doing these streams. I'll keep solving the other exercises as they come. There are 9 days already available, so they come one each day, until the day of Christmas. Um, and yeah, as I said, other things I want to do besides just solving them is going through them maybe later and refactoring them, and maybe taking a look at how would we write this code if it were part, if all of these little puzzles were part of a bigger application, you know like maybe even they all constitute a domain, like they are talking about a submarine, they're talking about depth, about certain different things, and maybe we could even turn this into a little application, like there are really little and small details that maybe you couldn't care less when solving a puzzle, but when dealing with an application you would care. For example, one thing I can come out right away, we're dealing with something called the depth. The depth is essentially a non-negative number. You would want to have a space for that. When you're dealing with depth, you're not dealing with an integer, you're not dealing with any integer, you're dealing specifically with a non-negative integer. That's what is a depth. So maybe there are more things related to depth that we can code into a class in this scenario using Ruby. So yeah, there are a lot of things we can check just by solving the advent of code puzzles. So yeah, I hope to make another stream like this soon, soon-ish. This is the first time I do a stream, so I don't expect many people to see this video, and it has been mostly a test. But yeah, I will solve all of this, and maybe I could make a smaller a smaller video later with the results of each example. I don't know, but we'll see. So thanks to Nacho, my friend. He has been here with me. He asked me some questions, gave me some advice. I'll try to get the audio from the PC so I can have him on the streams so you can hear him. He always have nice things to say. So yeah, um, that's it for today. Thanks, and I don't know how to end this.